Well, greetings. This is Tom Eckert, CST, coming at you live from Hattiesburg, Mississippi, in the heart of Dixie. Look away, look away, look away, Dixieland. Pretty excited. This has been a great start to a couple of training days. Love Hattiesburg, rich with history, laden with technology, and we've had a chance to come in and be part of a couple projects. So I want to just jump into to walk through some of the aspects of starting a project. We normally start with InfoWorks, and today I jumped into Global Mapper. It is by far the coolest GIS. I use it and run circles around Esri. And I do that only because of a mashup. It's got some LiDAR classification and map. So we go download imagery here. And instead of world and street map, here's some elevation data. I like this a little bit better. You can bring OpenStreetMap in, but let's see what we get here when we click on the elevation data and connect out to that. Brings it in. We've got a backdrop. Comes in. Should just take a second. And there you have it. Now we've got, this is the DEM elevation model in behind the topo map. And so as we look at it from the layering point of view, we can put this in behind. And when we bring the topo map up front, now we have, in a sense, the country shapefile, which is our original. Well, that's actually got 4,000 features that we don't need anymore. That was that overall world map just to get us on target. So as we're spinning here, now we've got the DEM in behind. So the first thing I'm going to do is I'm going to get rid of the country shapefile. We can close that overlay. And now all I've got is a topo map here with a background digital elevation model. And now when we go into our line of sight 3D path, click on here, we're going to go, well, let's hit a couple rivers over and see what that looks like. Moment that I hit right click on this guy, it's going to go out and process that line of sight from a three-dimensional elevation and use the forward-facing raster image of the topo map and pull from the data in the background image with the DEM. And here it is right here. So you've got your profile line of sight that it comes in. And in fact, when you're on here, notice that this is a low point here. When you move across, it gives you a location, which is your latitude and longitude. It gives you an elevation about 305 feet. This is the distance, 33 miles from the beginning here. So here's only 1.2 miles, and so you get a line of sight path, but it does follow that line of sight. In a sense, a quick profile is really what the aspect is. But this is a little glimpse at the elevation data that you're getting, and depending on the accuracy, it is one of the components that is a definition of a surface model when you bring it into Civil 3D. So we're going to be creating some surfaces. We've got a cool project that we flew, but when we look at surfaces, I really want to dial into what we're looking at. So say we get rid of the topo map here, and I'm going to close overlay. And that's what the line of sight looks like. And as a matter of fact, I'm going to close that overlay too. And one quick way, here's just a tip and trick for any of the users out there, is when it says open your own data file, a lot of times I'll pick a raster image. I'll just say, here's one right here. This is a particular valve. What the aspect of this valve is when you use that in the EXIF file, it's got a latitude and longitude, a GPS position on it. And in fact, depending on which camera you're using, this one is the Coolpix A130, you can turn on a compass and get information from the compass itself. So let me open up, in fact, let me just open up all these files. I'm just going to grab every single one of them, slurp them in, and now all of a sudden different layers, and I've got some geotagged photos. In fact, if I hit information, I want to look at them. What this photo is. When I click on it, there's a photo, and that's the building. We're over here at Clear Point Consulting Engineers in Meridian, Mississippi. And then it says, okay, well then I've got this picture. Where's that? And I'm facing, this is more facing southeast. And this vector will tell me, this little arrow will tell me what we're looking at. And so I did take a couple pictures of the flight. Here's the operator there. Will and Jeremiah are tearing them up. And we're doing a building model with the 3DR Solo drone. And so we're integrating some UAV data, but we're driving towards a surface. That's really what it's going to come down to, is the surface. So with those pictures, now that I've got it geo-referenced, it was basically open your own data file. When I come in and I start loading in some of the imagery in terrain, it's now going to know that I only have to pull in from this particular viewpoint. It's going to render a lot faster. It's going to bring in whatever's showing on the screen. Now this particular one, pretty flat because of the density. What we're going to do is we're going to add in our own UAV data to that data and realize here we're going from 34.5 to 341.5. So we have an entire foot. It does pick up a little grade break here in the parking lot. If I send this to the back, it'll tell me how it overlays with the pictures. I'll just actually send it up in there. And I can tell what elevation each picture is if I want. And so there's some really just quick and simple ways that you can use this information to keep elevation models. It's what's happening in the background of InfraWorks as you're bringing it in. So, so one last thing. Here we are, we're flying along, and I want to go over the measurements now. This is what the office looks like. We flew it with 135 photos. Remember what SiteScan is, this is SiteScan from 3DR. It's the enterprise version. Their relationship with Autodesk is getting stronger every day. But remember, clicking on the circle here gives you the individual picture. This is a nice shot of the rainstorm that was coming on our third panorama flight. We did 3 different elevations in a perimeter scan. And so as it got darker and darker, the initial pictures, the early pictures, came out quite light. And these guys were a little bit darker as we went along. I like that aspect, is because then we can pull the luminosity. There's a balance between bright light, which causes an albedo effect, too much white brightness, versus the rain is coming, get the last pictures on the last elevation perimeter. And so we did that. But after that, what I did is I flew and I just grabbed a quick polygon. I said, okay, well, we've got a building here. It's going to have a 3D aspect, and so I drew a polygon on here. When you click on your polygon, it's going to give you an area, and then it's going to come up with your cuts and fills. And so this is, and of course, is this silly? It's a building, but it's a great way to demonstrate the power and the performance with the SiteScan volumetrics. Because when we hit view and volume in 3D, it's going to grab the elevation data, just like we did in the global mapper. It's going to find out on the left-hand side what your orthomosaic in your site looks like. And then on the right-hand side, it's going to come up with a base plane. It's rendering now. And I love this aspect of it. There is so much analysis you can do. It's rendering. So your building is in blue. Your base plane is in brown. First of all, notice a couple things. The base plane itself is a 3D base plane. And so we thought, well, wait a second. The 3D base plane is going to come up here, and the cuts and the fills, it's not going to give us an accurate surface. So if you're doing volumetrics and you send your information up to the cloud, you're using an alternative product, and they don't establish the base plane correctly, your volumes are going to be whacked. So you can have 4 choices. You could actually do a level base plane here. When you switch that out, it's going to do a recalculation of the individual base plane. I'm going to turn it off, actually, and get it out of there. And then look at the 3D model on the mesh here. It's thinking. That's a pretty quick regen. There was a lot of math that went into that one. Now wait a second, we have on the fly an entirely different volume calculation, and what it did is it picked the level base plane, and in a sense it was the lowest. So look at this guy here. This is a sample at the what would be the corner over here in the building, right? So it'd be the back. What is it? That's got to be the west side over here. Somewhere over here it had a ghosted image of a car. Of course, there's some noise there of this car, and this car actually did not have enough pixel strength for a return, so the car drives by and creates a spike in our elevation data. So we've got that. Let me turn off the mesh so you can see it a little bit better. So instead of putting a car there, we got some trees. What is right over here? We got a billboard sign that we missed. We didn't calculate that in there, but there's a billboard right there. So quick 3D model, many different ways of looking at it. You can do a highest or a lowest elevation. With the base plane itself, it's entirely movable. What I really like is if you change the base plane elevation instead of 314, let's call this, I think it was a 3, let's call it 320, just for grins. Click on that, it's going to enter a value 319 to 320.06. So calculate the base plane. We can cut it off there and on the fly move our elevation here. Let me just turn it on so you can see it. Look at it re-render on the fly. That's a beautiful thing. So brought it a lot closer, got rid of some of the stuff. Word to the wise, if you notice, it is not exactly a flat elevation. There is an aspect of GPS measuring to the ellipsoid that provides just a little bit of a skew. And in fact, in this case, it's the 1 foot. Even if your parking lot without ground control points, even the parking lot itself would have some challenges of showing correctly. This is us. That's what a car looks like, by the way. Our big old truck looks like. There's the front door of the building. But we're going to go over more of that. I just wanted you to get a flavor for the different volumetrics. There are new aspects coming out every day. That twice a week get an email from 3DR with some new features. And in fact, we were just talking, we were doing some conference room training. We brought it in from the field, and we were saying, you know, this morning we came in and on the data layers, hillshade wasn't an option. We showed up in the afternoon and we have a whole new flavor, and so we spent much of the afternoon looking at it and going, well, what does that hillshade really mean? What does it look like? How about the cuts and the fills? And so we're discovering new features. It's so nice to be able to just to trust that 3DR is at the cutting edge of delivering value data dynamically. What we call data on demand. And so join us. The next screencast we're going to be jumping into what are these new grid buttons here to fill out on your data layers. Why would you even want to have them? And I'm going to end with this. Once we made our volume measurement, we've got it there. Remember, this share is amazing that whether it's a hillshade model, however you're copying it over, when you bring this in here, grab a new tab. I'm going to do a Control-V paste on the side scan, and I am sending out that orthomosaic with my volumes. And so any shareholder in the project can just click on the link here, and when they too click on the blue dot, they're going to get the area and the volume calculations that you submit to them. Any changes will be updated. Here's the link that you just send them, and great collaboration through 3DR SideScan Enterprise. I'm putting this into not only a screencast, but we're putting it into a PowerPoint. We've got some really cool stuff. Love to get this in your hands. If you get a chance, give me a shout out. It's a real simple email address. It's Eckert at atgusa.com. It's T as in Tom, and it's Echo Charlie Kilo Echo Romeo Tango at atgusa.com. Hope you have a great day. Signing out. God bless. Bye-bye.